You've seen it, right? Just the sheer explosion of data everywhere. I mean, it's streaming in constantly from every device, every click.
Hmm.
It's pretty overwhelming. And the big challenge, the real trick, is avoiding that classic problem. Garbage in, garbage out. How do you actually use all this data? Make it trustworthy. Well, today we're going to dig into something that tackles exactly that. It's called Delta Lake. And this isn't just, another way to store files. It's about making that raw data truly work for you.
Yeah, exactly. Our mission here is really to unpack what Delta Lake actually is and, crucially, why it's become so foundational for modern data systems, particularly these things called lake houses. We want to explore how it helps you get real insights, basically by fixing that garbage in, garbage out loop at the source.
Okay, so let's get to the chase then. For someone just trying to get a handle on this, what is Delta Lake? Like in simple terms, based on what we've looked at.
Well, essentially, Delta Lake is an open source storage framework. It came out of Databricks originally. Its main job is to bring reliability, think database level reliability, directly to your data lake files. That's the core idea behind this lakehouse architecture concept.
Lake house. So like combining a data lake and a data warehouse.
Precisely. You get the low-cost, flexible storage of a lake, but with the structure and, importantly, the AC transaction guarantees you'd normally only find in a warehouse. Delta Lake makes your data files behave more like structured tables, and it works with, well, pretty much all the BigQuery engines: Spark, Flink, Hive, Presto, Trino.
Okay, that transactional reliability bit sounds key because that garbage in, garbage out thing isn't just bad data coming in, right? It's also about things getting corrupted halfway through a process or partial writes, messing everything up downstream. How does Delta Lake stop that?
Right. That's a great point. It tackles this head on. The big thing is ACID transactions on the data lake. That means operations are atomic, all or nothing. Consistent, your data stays valid. Isolated concurrent jobs don't interfere, and durable changes stick. So no more corrupted files from failed jobs. It also enforces schemas.
Like a bouncer for your data.
Yeah, sort of. It checks that the data structure and types are correct before it lands. And if you need to change the schema later, it handles schema evolution too, so you don't suddenly break everything downstream.
Okay, so it's protected the data inside the lake too, ensuring integrity. Got it. What does that actually mean for, say, a data engineer or a scientist working with this day to day? How does it make their life easier?
Well, it drastically simplifies things that used to be incredibly complex and, frankly, error-prone. Think about trying to update records in a massive data set sitting in plain files, or handling streaming data reliably. That used to be a real nightmare in a standard data lake. Delta Lake adds features like upserts, so updates and inserts and deletes, directly on the lake data that just wasn't practical before.
Right, you couldn't easily modify files like that.
Exactly, and the commands become simpler. Our sources showed examples like people.read.format.load to read, or people.write.partitionby.format.save to write. It even lets you do time travel.
Time travel, like going back to see old versions.
Yep. Query the data as it looked yesterday or last week, or roll back if an update went wrong.
Yeah.
It just abstracts away all that complex file management stuff that used to take ages. Now it's often just a few lines of code.
So Delta Lake is really acting as that essential bridge then, taking the massive, potentially messy data we collect and making sure it can be reliably stored, processed, and turned into something genuinely useful, not just digital noise. It brings order, basically.
Absolutely. And that reliability, that trust in the data, it opens up so many possibilities. It makes you wonder, doesn't it? What kind of new things become possible when you can actually depend on your data's quality and performance? Especially for more advanced AI and machine learning across, well, every field.
That's a great question to ponder. How might this kind of foundational tech be quietly reshaping innovation all around us? Definitely something to think about next time you hear about big data or AI breakthroughs.